Hi, my name is Merlin. Today I'm going to talk about what I learned today. The thing is that I was retired, so I wasn't able to learn something really deep or new thing. And now I'm just gonna talk about what I'm doing in this month. So actually, I was making a operating system using Rust, but I found out that I'm watching the tutorial or the blog for it, but and the blog was really not sufficient because what I understand was bootloader. So what I understand making an operating system, you have to know about BIOS and like bootloader, bootloader, and there's an OS script kernel. But you there's already BIOS on your computer, so you don't have to make it. But the thing is that you have to make your own bootloader because it the what bootloader is does do is it boots your computer and it finds sorry find yeah find finds the OS kernel image kernel 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 image, and it sends to RAM and make it execute and execute. So that is how it works. So implementing bootloader is really necessary for you making an operating system. So but the thing is that in the blog what I'm watching is it doesn't talk about loading an OS kernel image, and that was really, really frustrating for me. So but also there was some misunderstanding of the code because it is written in Rust. I don't have zero knowledge. I have really literally zero knowledge, like 10%, like 5% of knowledge. No, 3% of knowledge of Rust. So I'm a front end developer, so I'm using JavaScript to make an operating system. But the thing is that you can't make an operating system using JavaScript because JavaScript is for your website. So what I'm doing is making a website, but works just like operating system. Of course, there's no bias of it, but there's bootloader and there's some kind of it. But how is that possible? Well, if you look at my code of it here, I specify the hardware specification of it. So if you're so which means that you don't have to care. You have to care about hardware, but the hardware in this my code is just the some buffer, some kind of buffer or some kind of list of array. Because even we trying to make something hardware level, low level code, we assume that we have hardware specification, hardware buffer of it. We actually don't know like really how hardware structure it is. We put some kind of key memory address to make a feature like 0xb8000, like something like that. So which means that we only know we have to know about some kind of this kind of data or some kind of buffer memory address. So which also means that I can just treat it as this memory buffer in the front end development. So this is the class. So in this class, if it got rows and column, it will generate the buffer and it stored the buffer on this private variable, and you're able to manipulate it via these methods. Like example, skip this. In the app, it initialized the canvas. So canvas in here is actually a laptop screen in the real world. I'm just making using canvas because canvas is gonna be convenient. And if you look at the code, the print lf is just basically it's just writing a string using this BGA hardware. So BGA hardware it's just graphics. In reality, BGA hardware, if you put some kind of text on your BGA hardware, it's gonna be printed on the screen. So I try to make it as a possible in front end development. So when you got string, you're gonna write the string, and you put the BGA hardware on it. BGA hardware is basically the global variable, so we can always reference it without hesitation. And after that, where there is no code of it. But if you look at this hook exactly reading the BGA hardware and it printing on the screen. So which also means that if you're trying to add some more, you're just gonna be up here like this. See this? And these are actually just seems like real screen in the operating system. So how does it work? So this is like this. So array buffer, when you got receive 25 and 80 array, and when we trying to put the H on the screen, we can just store in the 25 times 80 array. But in this word in under the hood, there is gonna be like hardware buffer of it, and this each boxes, there's always a boxes of it, and we store this string on this box. Actually, this is really hardware works. Hardware, I think it was like 8 bits. Yeah, 8 bits. So in BGA hardware, BGA hardware, there's a BGA text mode, and you can store a text in the buffer of the BGA, but there's a 2 cells of it per each. 2 cells, which means that there's a 2 room of it. 8 bits is for the text, the ASCII code of it, and another 8 bits is the color code. So how did I make this? If you look at the code over here, you can see this converting in color code. Yes, I made the converting a color code. If I specify some kind of like black, blue, green, red, whatever, it stored this specific hex code on here, and we can when we're trying to use it, print on the screen, we can decode it. And this is real example. This variable, these enum variables is from the real hardware BGA hardware specification, and the base R is GRXB8000. That is also part of BGA hardware, and the blink bit position is 7 bits, and background color position is 4 bits to 6 bits, and foreground color position is 0 to 3 bits, and there's also masking of it. Yeah, cell size is 2, cell buffer size is 16 bits, because we have 8 bits, and 8 plus 8 is 16, right? And we stored 16 bits and auto array, so we define of the buffer is UNI 16 array. So that's simple. I think this is done. I'm trying to implement the real CPU because there's a called mutex. So what I know about mutex is some kind of synchronization tool to block data arrays, but to make a mutex, it should be CPU, and to make a CPU there should be ALU. So I'm just gonna make a CPU in the Word. So I don't know what will happen. So this is it. So I don't know what we're gonna happen tomorrow. I'm just trying my best. I don't know. I can finish this in another 1 month. Okay, so whatever. See you next time. Bye bye.